connected the power leads for the new electronics cabinet to the spare socket on here. This is a two-way switch, so it's center off, a three-way switch, center off to the starboard. It's connecting the electronics cabinet to the starboard power system. The starboard power system powers all the non-essential equipment and the starboard motor. And if I connect it to the port, it's now powered off the port power bank, which is connected, charged by the port motor, and it runs all the navigation and autopilot and more critical things. So if I put it in the center, the electronics cabinet is off. So to do this, to test this, I've wired in a little battery tester to the either end, just temporary to check it, to either power connector. Fortunately, I didn't have the right colored cables, but I had the right gauge. So I've used some black tape to mark the negative cable. So I've put the power bank here. So if we see here, to port, I get 13.7 volts fully charged. It's actually charging off the mains. Starboard has not been charged, and it's running at 12.6, so I need to put that on charge, 84%. So off. So let's confirm that's all working. And inside the cabinet, I have wired this up to, I've got a fairly old system here, so I have basically posts for my distribution blocks, and my distribution blocks, I got one for negative at the top and then two for positive for port and starboard. So I've wired wires to those to the three-way switch, and then I've wired one wire from the center of the three-way switch to power the cable, to power the cabinet, and I've wired one from negative straight out to power the I've taped the power connectors out of the way, and I've just put in a cord which will go down to a screw eye on the end of the cord, which will stop the door opening too far and breaking anything. So it's going to hang horizontally from this when it's fully open. Then I'm going to mount two hinges, and then once that's done, start wiring it up and installing the Raspberry Pi and other components. I've now fitted two brass hinges to the bottom of the electronics cabinet, and I have also fitted a rope to it so it doesn't fall down too much when you open it, can support its weight. And I fitted the fuse box for powering the new electronics. I've wired that into the existing power supply through here, and I can run it off navigation or house or off. So I'm going to relabel this to electronics, and in here is going to be Raspberry Pi, SDR radio, a homebrew receiver for my wireless mast, direction and wind, wind speed and wind direction, and two Raspberry Pis. Actually, I'm going to have put two, a backup and a main one, just in case I have problems with one. And then I've got here's a little power supply. It's off AliExpress. It runs at 5 volts, 3 amps per USB-C. So I'm going to mount this to the back of here, and I've tested this. It charges my phone, so that will run each of the Raspberry Pis. And then, unfortunately, I've hit a little bit of a blocker. My hole saw, the shaft on it does not fit my drill. My drill chuck is too small, so I've got to go back and find another bigger drill from home to do the next stage, which is to mount the screen, the instruments, the switches, and the digital control pieces. So I'm going to use a mixture of low-cost portable screens, and I've got some 2K low power USB-C powered displays, and I'm going to use some old mobile phones as displays on this. I've got some interesting stuff for the switches, which I'll show you later on. So I may have to do this in 2 parts if I want to get this live, but I may wait till I've done the whole thing and then edit it together. Let us see what happens. Okay. So luckily I borrowed a drill off the boat next to me, and I've mounted the... I've connected up the first piece to the fuse box. So what I have here is a 12 volt to USB-A and USB-C QC and power distribution PD adapter with a voltage meter. So I've wired that up to the fuse box. So if we open this, I have the fuse box, I have from the negative bus bar and the positive through the fuse to the back of the device here, and I've just wrapped the cables temporarily. I'm going to trim these shorter and wire this properly once I've got everything checked out. So turning this on, actually let's just put the cover on here, and I can close this, can put this on, and we get 13.3 volts because it is charging on one side and 13.8 volts on the other side. So remember, I have 2 battery banks, one for the navigation parts and one for the living parts. And this switch center position is off. To the right it's running off the navigation bank. To the left it's running off the household bank. Okay, so I've plugged in the test meter, little USB power meter, to the other PD USB-C socket, and I have my laptop on the other end of this, and I'm going to plug her in and let's see what it does. Interesting, it's kicked up to 12.15 volts at 1 amp. The laptop's fully charged, so it's just negotiating, so it's cutting down to less than a tenth, like a 0.07 of an amp. It's kicked down to 5 volts because the laptop's charged, but the PD kicked up and it did charge it at 12 volts for a second. Let's switch back to 12, so that's good. So I can charge my laptop from this socket as well. Excellent news. So next I'm going to I put my screen on my nav desk, and I've got a little light which I'm going to use to illuminate what I'm working on better for the video recording. So I'm plugging that into my QC socket, USB-A, putting the light down here so I can illuminate what to do. I'm going to set up the Raspberry Pi, the SDR and the Knox guard just here on my nav desk, and then once everything is working, I'm going to do a first install. I haven't bought the waterproof cabinets yet, so this is not a permanent install. This is just a quick smoke test to check it's working. Hopefully no smoke. Okay. So here I have my Raspberry Pi 5. It's an 8 gig Raspberry Pi 5, and I suspect one. It's got 2 USB 3s, 2 USB 2s, a 1 gig Ethernet, I think, and it's got a little heatsink and fan on it, and I'm going to use that as my primary boat computer. It's going to be in a waterproof gasketed box to keep the salt and humidity off it, and I'm just going to set this up now just to test, make sure all the switching, everything is working. Of course, everything is non-standard. This has a micro HDMI, so I've got a little adapter for that, and the monitor has a mini HDMI, so I've got a little adapter to that. So I'm going to just plug these in. Unfortunately, I don't have 3 hands, so I can't hold the camera while I'm doing it. So in a second, you'll see it plugged in. Now, my HDMI cable from the Raspberry Pi plugged into my flat screen monitor, and next is to connect up my Air mouse / keyboard and the power for the monitor and the power for the Raspberry Pi. I've connected the power to the monitor, so this cable here goes up to here, and I've connected the power supply for the Raspberry Pi, and I can chain the Raspberry Pi off the monitor's power input. So let me connect that. I have the power for the Raspberry Pi going into the monitor, the power for the monitor going through USB-C from my PD 12-volt power, and the cable's connected. So now the Raspberry Pi is booting, and it's loading up a whole lot of open source software, and it's booted. Raspberry Pis are pretty pretty quick. So let me plug my Air Mouse in and see how things work. I plug my Air Mouse into the Raspberry Pi through a little extension cable, and now I'm going to find my Air Mouse. Got it. So here is my Air Mouse. So if I power this on, this round, I should have, yeah. So I'm going to zoom into the screen, see if you can see this. There you go. So when I move my Air Mouse, pointing at the screen, the mouse on the Raspberry Pi clicks, and I can do things like drag and start applications. So with this, I'm just going to open up. Sorry, this is a little bit wobbly. Open up two things. So I opened up my Signal K server, and I've opened up my OpenCPN. So Signal K is running here, and it's basically a multiplexer for boat data. It takes boat data from multiple sources and gives out boat data in multiple sources, and it has a plug-in API so you can plug in things. So that's all booted. Now I need to plug in my GPS into the Raspberry Pi. 1 second. So here is my GPS puck. It's a little magnetic puck that's going to be mounted somewhere out of sight. I've then plugged that into my Raspberry Pi. So now within a few seconds I should get a GPS fix. So what that will mean is this here will go from red to green. See what it's doing. So sorry, and this piece here will go from red to green. My GPS fix. Okay. Just going to test my Signal K is all, yep, everything is running okay. Okay, may just restart OpenCPN. It hasn't picked up the GPS chip puck. Just close this. Wait a second. So that has verified my openplotter install, and this is all the software it's running. So it's running a X11 display server, virtual keyboard, openplotter, openplotter packages, serial communications, OpenCPN, Signal K server, serial network, GPIO, power management, shutdown management, touchscreen, and it's all running okay, no errors. I'm just going to close that and rerun OpenCPN. Okay, let's see if it picks up the no, interesting. Why is this not working? Let's go to the configuration. Still thinks I am. Where does it think I am? Gosh. Okay, it thinks I'm in North. Where is that? So let's go a bit further. Okay, Finistère in France. So I was there hiking, so maybe I turned the OpenCPN on there while I was on. It's the last place it was locked on with the GPS. So let's find the openplotter. Now this will be on a sort of virtual serial port hanging off the USB ports. Let me just check that that is installed correctly. So we have a USB port. Let's try details on that, see what it is. So that is a serial FSC TTY. And this one is a details on this. Okay, it's a GPS. So that is working. Let's refresh this. Okay, so the GPS still remembered type. So let's just make sure. Let's just put this as using my little keyboard. GPS, and let's say that it outputs NEMA data. Yeah, NEMA 1083. Let's apply that, and looks good. It's gone green. Refresh this, and let's connect that to signal K. NEMA connection, add to PiPilot, add to GPSD, okay, add to signal K. So let's add it to signal K. Auto. Okay, that's perfect. That fixed it. So now, if you look at the little corner here, I have some satellite signal data. I have 2 bars out of 3. I can close my serial configuration, and I can hit this little button here to go to where my boat is, and there we go. GPS has locked me into the Clyde. I can zoom in a bit. And Scott, let's just zoom out so you can see where I am. So I am currently in, not Iceland, not Greenland, Scotland. And let me zoom in. So I'm on the Clyde, moored into, okay, it's a little bit of a map glitch there, not much actually, that's working, in the James Watt dock from the old sugar port on the Upper Clyde in Greenock. Let's go in one more. There we go. And I'm in, says this, 17 meters of water. It's a deep water dock for old sugar ships coming from the Caribbean, bringing the sugar to Europe. There's a little bit of a dark history with slavery. It was, most of the sugar was farmed by slaves. Very unfortunate time for the world. And then if I go out, yep, that's into the Greenock public dock, and yeah, there we go, it's all working. So next I'm going to set up the AIS, and I've got two more USB ports free, so let's plug that in. So 1 second, find it. That's my RTL SDR, and I've got a little test antenna connected to that. I've rebooted my computer just to make sure this is working. Here it goes, Raspberry Pi is booting, and let's see if it picks up any SDR AIS targets. So what I need to do, let's do a check. Everything is working, including, yep, it's good. And I'm going to run OpenCPN. Out. So this whole thing is running off one PD socket,
through USB-C, and I'm going to shut it down and boot it up again to measure the ampage. So it's picked up the it's picked up the GPS. Just going to reset this back to where we are. And make this full screen. Okay, so we are in St. James Watt Dock. I'm going to zoom out a tiny bit. There we go. And I'm going to check why my SDR is not working. So let's go back to settings, OpenPlotter, serial OpenCPN dashboard. Okay, let's go back to OpenCPN. Let's go back to settings. Let's check that the SDR stuff is installed. So refresh this. Second. Sorry about the wobbling. I need a little tripod and better camera. So here we go. So I have got Signal K dashboard. SDR VHF. Okay, so I think I need to install SDR VHF. So let me just refresh this. Refresh. So just press the refresh button. Okay, and scroll down. Got a lot of things installed as SDRs. SDR is not installed. So what I need to do is install this. And why won't it install? It's in the install button. Let's refresh this again. It won't install because I have no internet connection. Okay, let me connect this all to the internet, and then I can install SDR VHF to do the AS. 1 second. Okay, I'm actually using my phone, which I'm recording this on, as my hotspot. So just switch the hotspot on, and I'm going to it's my mouse. Okay, I need to get a bigger mouse pointer. So zoom in onto here. There. Tom's phone for the internet connection, and I'm going to put in my password. I'm just going to switch off while I do this. 1 sec. Okay, I have an interesting problem. The problem that I wasn't expecting. What it means, I have to delay this filming for a few hours, because if I move over here, move out from there, go across to my door and look at the harbour wall, I can see lots of mussels, and I can scroll up and up and up and up and up and up. I am kind of low down in the harbour because the tide is out, and my 5G cell tower is behind this huge granite wall, a few miles behind it, and when the tide is out, this completely blocks my 5G signal, so I don't have an internet connection, which is kind of annoying. So when the tide is in, it floats up about three or four blocks down from the top, and my cabin is peeking out over the top, and I get a really good, like, 200 megabits 5G signal. But at the moment I have zilch. So let me see if I can do something about that. Hold on. Maybe I'll connect to the Marina Wi-Fi.
So I could not connect to the Marina Wi-Fi, so I decided to go for a cycle ride while I wait for the tide to come in. So I'm cycling up the Clyde on my orange bicycle. It's cold, but the sun's out, so you can see a rainbow across the bay, across the river, and you can see snow on the hills on the opposite bank, which is kind of interesting. I'd love to. And here is a Newark Castle, which I've visited a few times, just next town over, so I'm going to cycle a bit further and head back to the boat.
Good morning. It's the next day. It's raining and windy today. The tide has come in and out and in again. So the boat is almost at the top of the granite harbour wall, and I have internet. It definitely blocks my internet when the tide is out. It's quite a high tide reach in this harbour. So I have tweaked everything and it's all working. So I have my Raspberry Pi. It's connected to the monitor via HDMI. The monitor is powered by a PD USB-C. The Raspberry Pi is powered by a PD USB-C, and it has plugged into it the SDR dongle, a Air Mouse keyboard dongle, and a USB puck here, USB puck, and it's all working. So if we look at this, we can see the red boat in the center is me. There's a lot of wind in the harbour, so boats are bobbing around a bit, so it's giving me some false collision warnings. You can see there's a bit of boat movement. There's a boat going down the channel, and there is a boat heading out of the harbour, out to the channel. So and there's a few boats moored with AS, and then in the North Harbour above me is the tugs, and they're all giving me collision warnings because they're moving with the wind. So I've turned off the sounds because it's a bit annoying, but you can see it's saying this boat will collide with you in half an hour, because they're moving slowly, but they're moving because of the wind backwards and forwards. It's generating false collision warnings, but I usually turn AAS collision warning off when I'm in the harbour, just because it false triggers all the time. It's designed for working in the channel out at sea. So that's all working. So next stage is to install it in the cabinet. I don't have the waterproof box for the Raspberry Pi, so I'm going to have to go and buy a waterproof box with a gasket and mounting screws. And I found a couple of problems. One main problem was the internet was down because I was behind the harbour wall. The second problem I had was my 12 volt PD USB-C power supply. If I ran the whole thing off one USB-C plug and then plugged that into the monitor and then ran the Raspberry Pi from the monitor through USB-C and USB-C power out from the monitor, it would all work until I plugged the the SDR, software defined radio, in. When I plugged the SDR dongle in, it would shut down because it didn't have enough power. So I'm now running it off two separate PD sockets, and I did some testing first. Some of these Chinese cheap, it's cost me like $9, cheap £10, no, £7. These cheap PD supplies, sometimes they're just a bit fake. This one is giving true PD. I test it by putting the test dongle on each socket and then taking power of each socket. Some of them only have one PD, and if the voltage changes on one, it changes on them to blow up devices. This one has separate PD chips and separate QC chips, so it's working fine. So I might get a second one of these to mount internally inside the cabinet to power everything, because I think this is the best one I've found so far in terms of reliability and functionality. So that's good. I'm running with some test maps of the local area. So I've got two panes, one showing the Clyde with me zoomed out so I can see long distance, and then another one is close up showing the harbour, the channels and the decks and stuff. So hopefully if the weather improves, I can take her out for a sail and get some proper ones. There's a number of ferries across the Clyde, and AS is going to be very useful to tell me am I going to pass in front of it or am I going to pass behind it, because they do sort of slightly curved courses. You never know exactly where they're going because they move with the tide and the ferry terminals. So it'll be interesting. This is all working. The next job is to put it into the cabinet. So the cabinet's here. I've got some trim wood to put around the display. I've got a lock for the cabinet. So I'll do some video clips. I won't do the whole thing because it's not going to be so interesting doing some woodwork, but I'll do some clips of putting everything in the cabinet, and I'll show it all working and installed, and then I'll head off and get some boxes. Probably in the next episode I'll put it all in waterproof boxes and shockproof it all, so it's all marine grade, because none of this is marine grade equipment. It's all sort of fairly low cost equipment. I've also got a connector for I've got several VHF antennas on the boat, and this will allow me to put my SDR into a mast top AIS antenna. So I'm going to connect that in as well, so that'll give me much better reception. I can probably pick boats up like 30 kilometers away on AIS. Yeah, so that's it for today, and watch for the video next week. Well, I'll be doing some more work either on my boat watch project, or which is actual watch, not a sort of lookout watch, open source watch showing wind and depth and stuff. And I'm going to do some work on some of my in-cabin display pieces. Yeah, I'll show you those next week. They're rather interesting. Okay, thanks for watching, and see you next week.